so that when we pick a data set, we're actually going to explore the data set, do the data cleaning and pre-processing. We explore the data sets, analyze it, make some meanings out of it, and we also build machine learning models to, predict future values, for us. So that is the approach we're going to use for now, and I am more than excited to embark on this journey with you. So without further ado, let me just jump into today's um, today's session with you. So I know Nanamo has done his best to um, explain the concepts to you. If you haven't really gotten it, probably today you can bring all your questions and you'll be answered. So first things first, today's session is actually, like I said, about exploratory data analysis. And as data professionals or data scientists, you are seeing some like somewhat like a data doctor, and everything you do is all about data. So if you have a way to, I mean, and there is a way you can actually make meanings out of these numbers and images and whatever data it could be. So you as a data scientist, your goal is to pick that's I don't want to say gibberish, but it's more like it's raw. It doesn't make sense when you have columns, people's names and age. They don't really make sense, but it is your goal to actually pick those ones or those data, transform them, perform your magic on it, and make some meanings out of it. And you'll be able to inform somebody that someone coming to your shop, having the person's name and this blah 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 can help you do this, and this is what I found about your business, and I think this is what is good about it. This is what's so good. I think this is what you should do. I think it's going to be great. So that is what data scientists seeks to achieve, and you can never achieve this without the concept of EDA or exploratory data analysis. So as part of your I mean, as part of a data scientist life cycle or duties, most of the times after getting your data, doing all the data cleaning and pre-processing, you would have to actually analyze the data to make some meanings out of it and to know your way forward to modeling. So the next step after getting your data into the right state or after cleaning your data sets is actually exploratory data analysis, where you analyze the data thoroughly. That is why it is saying exploratory. You are exploring. You have to explore the data. And if you are exploring something, you don't know much about the thing, but you are now analyzing the thing or diving deep into the thing to actually find whatever is missing or whatever is hidden, sorry, in there, and then you make good use of it. So this is what this concept actually seeks to achieve. So up to this point, we assume we know our data. We know different types of data sets which we know, and we know data validation state. We also know what we want to achieve, and we know data cleaning and pre-processing. So at this stage, you've cleaned your data, and it is as cleaned as it could be. And now let's proceed. So when we talk of exploratory data analysis in the English context, you would say that EDA is the process of analyzing and visualizing data to extract insights and identify patterns. So the key thing here is you are doing data analysis, and with data analysis, it has only one goal, that is to what? Extract insights. You are to extract insights. If you are exploring something, your goal is to what? Get some insights, get some information from that. So they say that curiosity kills the cat or something like that. So more like a data scientist is always curious. You want to know more about the data you're working with. You want to know more about what is behind the data you are working with and all those that. So it is really amazing, and that is it's all about EDA. So whenever you hear EDA, I want you to keep in mind extracting insights. Or whenever you are embarking on an EDA process, your goal is to extract an insight. So whether you are successful or not will be judged or will be determined by whether you were able to extract some insights, and make sure your insights are meaningful and you are good to go. So it's here that it helps you to understand the data we are working with and prepare it for modeling, like I said. So you actually want to understand the data, one, there are two purposes. There are two ways you use the insight. You use it for your next step, that is modeling, building machine learning models. So you want to understand the behavior of the data sets, the behavior of the customers, the behavior of the temperature or whatever. What are the hidden things in it? Now, if you get this, the next thing is to actually use this information, either communicate findings you had to the stakeholders or whoever you are reporting to, or you actually use that information, pass it on to the modeling stage, which we will see tomorrow, God willing. I mean, inshallah. So there are actually several steps in the process of EDA, and some of them include data cleaning. And you understand, you see, you finish cleaning your data, but once you start analyzing, you will see that okay, I needed to maybe do this thing I didn't do. So you have to, do it again. So something like that. So you can do a second data clean where this is not really removing a lot of things like first, but probably some few technical things you can do. But there are three main types of exploratory data analysis, and I'm going to switch from saying exploratory data analysis to saying EDA. So anytime I say EDA, you get it in mind. It is exploratory data analysis, not only today but for the rest of the course, or even in your works you hear a lot. Most experienced data scientists, or even starting ones, will say EDA, EDA, EDA. EDA is exploratory data analysis. So there are three main types of EDA, and then the first one is univariate analysis or data analysis. The second one is bivariate, and then the last one is multivariate. So it is step by step. Most of the time, when you're working with um, data set, you start with univariate before you go to bivariate and you go to multivariate. So univariate analysis is actually looking at how you pick the individual columns, the variables you are working with. You explore them. What is the highest amount paid? What is the proportion of, what is the gender balance? So if you are picking gender, how many were male, how many were female, how many categories did we have, and all those stuff. So when you pick, the first step in EDA is, or in data analysis for a data scientist, is to what? Pick the individual values, pick the individual columns or variables and explore them. That is univariate data analysis. And after exploring, or after doing your univariate data analysis or exploring the individual variables, then you move to the next step called bivariate data analysis. So with bivariate data analysis, you are actually looking at how to, by means to, how two variables actually talk to each other. What is the relationship between two or pairs of variables? Two variables. So what is the relationship between gender and expenditure? Probably maybe ladies spend more than guys because they get their money from guys, or maybe ladies spend less than guys. What is the average expenditure amount of my customers per gender? Maybe on average, females spend 20 cedis anytime they visit your shop. They visit your shop, or maybe men spend 15 cedis anytime they visit your shop. So you are looking at how gender and then purchasing power, or the amount of money spent on visit, are actually relating. And you could also be looking at gender and weight. What is the average weight? What is the median weight? What is the highest weight per each gender group? So you're looking at how one particular variable, relates with the other. That is bivariate. Two. Now, after bivariate, looking at the how two variables interact, you want to extend it beyond two. So from three going or more than two, we call it multivariate analysis. Probably you want to see how purchasing power um, vary across gender and location as well. So not only gender, but location as well. And I think it makes sense. You want to see, okay, maybe probably not just gender. You don't want to see the average amount of money your customers spend anytime they visit, or a customer spends anytime they visit the your shop. Let's pick Josephine's cake shop as an example. And Josephine, pardon me if I hope I hope permission is granted to use your shop for the analysis. Okay, thank you very much. So let's take Josephine's cake shop. Josephine wants to has data of her customers. Now Josephine wants to launch advertisements, but she has to understand her customers first, know the best channel to reach out to her customers, and then the best way to actually, um, help her customers, something like that, or to actually maximize profits and sales as well. So Josephine looks at what is the average, amount each gender spends whenever they visit her shop. So that is by varied data analysis because she is looking at how gender and then the amount of money spent actually relate. So Josephine finds out that on average, female spends 20 cedis on every visit. Whenever a female, like females, their average um, expenditure per visit is 25 cedis. That of guys is say 50 cedis. So it means that what this information will mean to Josephine is that okay, if any person or any customer enters my shop and this person is a female, if I actually do my business well with her, if I'm able to convince her, I expect her to spend at least, or I expect her to spend 20 cedis. And then if it is a guy, it will go up to what, 50 cedis, something like that. So that is the kind of info Josephine can get from this kind of analysis. So maybe Josephine wants to extend it further. Probably it is not just gender. You just don't want to. I mean, in normal sense, always making generalization is very dangerous. You have to make yourself to, make sure or do your possible best to bring them to as lowest as you can. So something like instead of saying, "Oh, female spend this," it could be that not all females from every place or every region in Ghana actually spend the same thing. All of us know, with all due respect to those who live in the north, that the northern part of Ghana and the southern part of Ghana are not the same. Life in South is actually very, very easy. I mean, as compared to relative to the North. So if you live in the South, it's easy to make money because you have cities, all the cities, almost all the cities are in the South. And there is a lot of money flowing in Accra and Kumasi, Takoradi, Cape Coast, and all those stuff. But if you live in maybe some place in the Upper West, probably life is quite hard for you. So if you visit a shop, it could be that location could also influence. So not just saying that okay, because this um on average females spend 20 cedis, any female who enters my shop is expected to spend. So Josephine can extend it further from comparing two variables, that is gender and then expenditure, and add location to it. Say that I want to know the how much the each gender class actually spends, on average, also relative to where the person's location. So now we are going to have male from say Ashanti region, female from Ashanti region, how much do they spend? And then male from Greater Accra, female from Greater Accra, how much do they spend on average? And those ones. So that one will help you understand even further or better, looking at variations across a lot of factors. So it is exploratory data analysis is actually one of your secret source or ingredients, as a data scientist. That is how, or it is this that actually wows a lot of people. If you have a client you're working with and you are able to tell the client, hey, this and this and this, the client will be like, wow, like this is what data science is all about. So you being able to understand, make meanings out of the numbers they don't see or they don't find any word from, and then using that same insight, communicate it and make suggestions to the person, and the person takes and make decisions upon that, and the person sees results. That is who a data scientist is. So now we've seen the three types. We have univariate, that is individual variable, bivariate, two variables, and multivariate, that is more than two variables. Now we've seen visualization here. I don't want to talk much about it because visualization is actually charts, bar charts, pie charts, and all those stuff. Whenever you're doing analysis, because you're going to communicate insights, you always want to you always want to present your findings or your findings or whatever you are communicating in chats. So instead of going vague with just everything in your head and talking, you want to present, for example, on average, or let's say if you want to look at the gender balance in the data set, you can do some pie chart or some bar chart and then show the person that not just talking, you can see the bars or you can see the proportions of the bar chart. Very, very nice. So we actually do exploratory data analysis most of the times, or let's say most of the times with visualizations, or we will say that visualizations, or that is graphs and charts. When I say visualization, I mean visualizing things in data science means creating charts. These charts are like scatter plots and all those stuff, which very soon we will see a lot into. We will actually going to dive deep into that. So when you're doing exploratory data analysis, your visualization is key. It's a key ingredient. Always don't forget. And the best data scientists mostly, or to make things easy for you to communicate your findings, you should be able to, give good visualizations. We have every chart has what we actually use to represent. We all know that histograms are mostly for distributions, and then bar charts are also for looking at how something varies across particular classes. So we will take time to understand these plots further, and we take it from there. Yeah. So at least you've been able to. I mean, for this particular slide, you've been able to understand. What is. So here I try to put some code samples here about data cleaning, which I know deleting rows and all those, deleting missing rows and all those stuff. We've tackled them already, so I'm not going to talk much about it. But when we look at it, let's look at the types of exploratory data analysis. And the first on our list, as we all know, or we just got to know, is univariate data analysis. And like I said, univariate, that is uni, means or it involves analyzing the individual, variables, or in other words, columns. So some of the things you could actually do, or one of the most popular things we actually do is histogram. In histogram, you plot histogram on the particular variable, and we always plot histogram to look at the distribution of that particular variable. And when we say distribution, it simply means how that variable is actually, distributed, how it is spread out, how is it presented, something like that. And we have two main. Most of the times, we have two main, categories of data you mostly work with. So if you have a particular variable, it may fall into two main categories of data types. It's either it is a numerical, the data, that particular column is numerical, or it is categorical most of the times. So numerical, we all know that is something like age. So you have, okay. So Josephine, very soon I'll show you, I'll talk about the histogram, the difference between histogram and then bar chart. So what I was saying is that when you have each particular column, there is high probability that particular column is either having numerical values or categorical. And numerical, I mean something like age, amount, and those things, numbers. Not just numbers, but these numbers are not categories. They are like continuous values. So my age is this, Josephine's age is this, and those stuff. So that is one thing. And then we also have variables where these variables or this particular variable, the values in the variable is actually categorical, something like gender. So we have categories, and each particular person or each particular customer in the case of analysis or example we are using here can be either, for example, gender. It can be either male or female. You can also take something like location. So we have 16 regions in Ghana. We can come from any of them. So we have like categories, predefined categories, and then the customers can be in this one of these categories. Some of them you can be in more than one, or it is exclusively or explicitly being in one class or one particular category. So it is very simple, as simple as that. When it is numerical, it's you. you see something like age, amount, and those stuff. But when it is categorical to, categorical variables are like gender and those stuff. Those with categories, gender, location, job type, those stuff. So um, when you're doing univariate analysis, most of the times, if the variable is continuous, or in other words, numerical, like age, like amount, you want to look at the distribution. How is it distributed? So to look at the distribution, you use histogram. Histogram is actually what we use for um, what we use to show distribution of continuous, variable. I don't know whether I have a histogram here. So this is a histogram, yes. So this is a histogram. Now, if it is categorical to, you do a value count and then you mostly plot it in a form of bar chart or pie chart, either bar chart or pie chart. Now, the difference between Josephine, now to your question, the difference between histogram and then bar chart. Now, let's first look at how their physical appearance first. Histogram and bar charts are almost the same. They are all bars. But with histograms, the bars are together. There are no spaces between one bar and the other because it is looking at how variables spread across different categories or different places, or data points. But with bar charts, you see that the bars are, separated. So we have one bar and then we have another bar by the side. I don't know whether I have bar chart here. So yeah, so this is a bar chart. So you can see with the bar chart, we have difference between, some spaces between the bars. But with histogram, you don't have um, any spaces between them because it is used for distribution. Now let's come to the should I say contextual, or yeah, they are more statistical meaning. Let me say statistical meaning. So with statistical meaning, histogram is used to look at the distribution of, you know um, a particular variable. So for this example, you could see that chunk or majority of the bars are higher between somewhere around negative zero, sorry, 1.2, like here, around here, and then between negative 1.2 and then roughly 1.8, something like that. So chunk of the bars are there. So it is telling you that if this was, say, let's say amount, then it is telling you that most of them, if it is the amount of money they spend, most of them are likely to spend between, where most of the chunks are. So to look at the distribution of a continuous variable, you use histogram. But if you want to look at the distribution of categorical variable, you use bar chart. And with bar chart tells you how many values or how many occurrences are in each category. So how many females do we have? How many males do we have? How many doctors do we have in the occupation list? How many business people? How many actuarial people? How many teachers? How many data people? We get a thing. So each bar in bar chart represents one category. So each bar in bar chart represents one category. So in this case, you can see this bar is for category A, this bar is for category B, C, D, and E. And then the length of the bar is determined by the frequency, that is the number of occurrence, or the number of occurrence of that particular category. So if it is gender, the height of the bar will be determined by how many people are male. So the height of the male bar is going to be how many people are actually male. And then that of female will be the same thing. That is for female. Something like that. So I don't know, Josephine, whether I've been able to I mean, explain it to you. Is it cool? Okay. I'm glad you do. So back to what I was saying. So we've seen, I think this your question has even helped us to actually explain some of bar charts just like that. So we've seen histogram. Like I said, I'm repeating. If you have if you have a data set and you want to do univariate data analysis, and if you don't know anything, the first thing you have to look at is to look at the distribution of each independent variables. And if you pick a particular variable, ask yourself, is it numerical or categorical? If it is numerical, you look at the histogram, you plot a histogram, and then if it is categorical, mostly either pie chart or bar chart. Now, to determine between pie chart or bar chart, most of the times the reason why we don't like using pie chart is that if there is a lot of, let's say, categories in a particular variable, let's say there are 100 different occupations in the occupations variable, you realize that there will be a lot of fractions. And if there are differences or the differences between one group and the other is not really significant, it is hard to see by the size of the little portions of the or the segments of the pie chart. But it is very good when you have, let's say, two or three different categories, and then their differences are quite, um, they are not really, they are not really the same. They are quite significant, something like that. Now, let's look at some of the next univariate data. I think I jumped some of them. So that is some of the univariate stuff you could do. And when we come to, let me use the chart first. So we can, after histogram, we can also do um, probably other charts like scatter plots. Now, scatter plots can be for maybe, but mostly it is used for bivariate. It is mostly used for bivariate. Or let me probably explain them to you before I come to um, the charts. Now, we've seen something about invariant. For bivariate, we all know it involves two variables, and one of the most popular bivariate data analysis to always do is to calculate the scatter plot or to calculate the correlation. To plot the scatter plot or scatter to plot or visualize the two variables using scatter plot. And then you can also calculate the correlation of two variables. Correlation measures the relationship. It measures the strength and then the direction of the relationship between two or more variables. You know, you want to see if something is going up. A typical example of correlation, if you don't know anything about correlation, it is more like, we use this word a lot, like, Charlie, the correlation between this guy and this boy party. Meaning that, sometimes we use it wrongly, but at least it's sometimes right, most of the time. So correlation is actually a mathematical or statistical measure to measure the relationship between to measure not just the relationship but the strength, how strong or how weak the relationship is, and then the direction. Are they moving in the same direction or they are moving in the opposite directions? So that is what correlation is. It is used to measure the direction and the strength of the relationship between two or more variables. Now, correlation varies between -1 and 1, and then the closer the value gets to 1, the stronger. Now, or correlation varies between 0 and 1. The closer the value gets to 1, the stronger the relationship. Now, if it is positive, it means that all of them are moving in the same direction. But if it is negative, it means that they are moving in opposite directions. So if this one is going up, this one is going down. This one is going east, this one is going west. If this one is going north, this one is going south. But if it is positive, then it means that all of them are moving in the same direction. As simple as that. Now, scatter plot 2 helps you to look at how a particular how, let's say, particular variable spreads across another variable. Like, how are they related? So something like, I want to see location and say location and, or let me put this way, we want to see premium insurance premium, and then the insurance what do you call it, benefit paid. You want to see the relationship. Maybe your this thing will tell you that the more you pay, the more you get, something like that. So let's say hospital treatment or hospital satisfaction, and then the amount of money paid. So maybe the more you pay, the more you get satisfied, you get a satisfactory service. So if that is the case, if you calculate the correlation, you would see that the correlation is positive. And if that relationship is very strong, in other words, if that is very, very true, you would see that um, your value will be very close to one. Yeah. And if it is negative too, it means that it is not true. Probably when you pay more, you get worse. You get worse. I mean, service from them, something like that. So let's look at scatter plots. This is a scatter plot. I mean, these things are readable. You can read them. I don't want to go into that. But this is how a scatter plot actually looks like. So we have a variable x and a variable y, and we look at how they are related. Now, if you have this, which we will come very deep into it, when you see how they are related, they kind of like, it's like a straight line, not very, not, it's not clear, but it looks quite this is a positive relationship, or a positive. If you do the correlation, you will see that it will have a positive correlation, because the more, if you look at it, you will see that it's like going this way. It is more like from the left to the right, it is going, it is moving upwards, it is having a continuous upwards trend, meaning that if you increase the value at x, it is also increasing the value at y. If you want to see this, you can trace at any point a particular dot, trace it to x and trace it to y, and go to another dot which is ahead of it, and trace it to x and trace it to y. You see that x is increasing, y is increasing. It's not the same for all of them though, but it is the same, the situation for most of them. So due to that, the correlation, this has a positive correlation. If it changes, if the bar was to be like this, then probably it suggests this, or it suggests a negative correlation, which we would dive deep into that. And well, the number, the correlation, the coefficient, or in other words, the number or the correlation. I mean, we call it correlation coefficient. That is the number when you calculate the number you get. The correlation coefficient would be determined by, sometimes visual. This thing can be misleading, but um, with this thing you can actually, with calculating the correlation, you can conclude on stuff. Now, another popular chart or visualization type to mostly use for your explore bivariate data analysis is also heat map, which we will see very soon. Heat map, but it is mostly used for multivariate. We would probably see in our subsequent, I mean, meetings. And we have a lot of them. We've done most of them. You can, we will explore more too as well. So that is it with today's. This thing is brief because it is a presentation session. We will do more when we do in the coding. Yeah. Just when your hand is up, you can ask a question. Or it's mistake. I think it's mistake. Yeah. So back to the teaching. Tomorrow we will do more. I mean, from tomorrow going, we will do more. So now let's look at multivariate data. Okay, just when you can talk, please. Oh, I guess it's a mistake. But if it's not a mistake, you can unmute yourself and speak. Now, without further ado, let's move to multivariate analysis. We already know multi-credit, multiple. So multi means more than, two. I mean more. So more than two is multi. And in mathematics, I mean in our context, I'm not saying in English. I mean in statistics or in mathematics, in data science, that is the or in this context, that is it. So here we want to explore how a lot of variables interact. That is the right data science word to use. Interaction. You want to look at the interaction, how they interact with each other. So you mostly want to. So one of the most popular um, most popular way to look at that is to use correlation. Correlation is both can be used for both bivariate and multivariate analysis because you can calculate correlation of two variables or I mean two variables or more. So if you calculate more than two, it becomes multivariate, and then if you calculate more than just two, it becomes bivariate. Now we also have a visualization type called heat map. Heat map is mostly used to represent correlation because when you have a lot of variables, it becomes quite difficult to see, to trace. So when you have a heat map, it's a small boxes. It is a big box with a lot of small boxes in it. You can just Google and see what heat map is. And the deeper the color, the stronger the correlation, or any other way you want to, which we will see very, very soon. From tomorrow going. So that is it with multivariate analysis. Now we've already looked at some of the popular, visualizations we mostly use in data, science, and we've looked at bar chart as well. Box plot. So box plot 2, yes, I forgot this. Box plot 2 is used for both. Box plot can actually be used for everything. It can be used for univariate. For univariate data analysis, you can use box plots just as you can use what do you call it, histogram. So you can use box plot for numerical numerical variables or a variable which has a numerical property to look at the distribution. So if you don't know box plot, this is box plot. This is how it looks like. This is a box plot. In other words, the actual full name is box and whisker plot. So the box is the blue thing, and the whiskers are the lines there. So the black line, in the center of the box is actually the median. It represents the median. And then the lines or the whiskers, the hands are the whiskers. So they give you that, like the distribution, the limits. So if you want to detect outliers in any variable, box plot is actually one of the best ways. And if you also want to look at the distribution of a particular variable, box plot is actually the best. So where the box actually falls, the box falls tells you where majority of the variables or the records are actually located. And sometimes you see some small circles outside, the whiskers, the lines, the horizontal lines going on, the hands. You see the hands. So anything outside the hands, small small boxes, those are outliers. They kind of depict to you. So box plot can be used as the same purpose for histogram when you do univariate analysis, or you can use it for checking outliers. And when you're doing bivariate analysis, you can also look at how a particular variable is distributed across another variable. For example, how amount of money spent upon every visit, or how purchasing power spreads across gender. So something like that, you can use box plot as well, and then you will see the shape as well. For multivariate to maybe more than one, more than two comparison, you want to compare with how let's say purchasing power varies across gender and location. So not just only gender, but location. So here we're going beyond two variables and you are entering the fields of multivariate data analysis. So box plot is something we would also be using most often. And once we start using it, you would really understand it very well. But I always strongly suggest if you are curious, you just Google it. Within 1 minute, you are good to know. Yeah, from there. So these are some of there's a lot of, millions of charts we can do. We have the violin charts, we have horizontal bar charts, we have a lot of them. Uncountable, and all of them are for different stuff. And I will do my best to, use them most frequently so that you get familiar with most of them, and you can also use in your, you know, works. One thing or one tip I'll give to you is that Now in data science, we have a popular say that pictures speak more than numbers. People are easy to see. It is very easy to see a number, or sorry, see Ma- Martin. I don't know if you can mute yourself for me. Thank you very much. If you are asking a question too, maybe you can type it for me, or you can mute or mute yourself and then you ask your question. I think maybe it was a mistake. Martin, if you have a question, you can actually type it. Thank you. So one tip I'll give to you back to what I was saying is that there is a say that pictures always speak, or they always tell a better story than numbers. If I have a lot of percentages and I asked you if I have 10 numbers which are percentages and they are very close to each other, and I asked you which one is the biggest, you would have to scan through, compare before. But if I plot it um, in a form of what do you call it, bar chart, and ask you which one is the highest, it is easy for you to tell me that okay, the highest will be the one which has the longest bar. Simple. So to be able to communicate your insights smoothly and efficiently to even non-technical stakeholders, because as a data scientist, if you are in a firm, most of the times you will be communicating with people who are non-technical. Non-technical, I mean people who don't know data science like you, people like salespeople, like the CEO, like the managers, like the HR and all those. They don't know your codes, they don't know much statistics as you. So you try to be in their shoes and explain to them. So one of the tips or one of the easy ways of achieving that is to using a lot of visualizations. And mind you, every visualization, like I said before, every data visualization type has, a particular scenario you be used for. So, like I said here, the choice of visualization depends on the type of data and the research question. Here, research question, I mean what you tend to achieve. If you have a numerical, data, you don't use a chart which is used for categorical. You get it? And if you have a categorical tool, you cannot go and look at correlation between a categorical and a numerical variable. You look at correlation between numerical variables. Correlation is a statistical measure for numerical variables. So you make sure you actually choose the right visualization type. Sometimes your charts can be of nice color, but they don't make sense because you are using wrong charts for I mean for wrong stuff. So it makes comprehension very difficult and it makes whatever you see very bogus. So my goal here is to actually, by the end of your time here, to show you a lot of the visualizations um, as possible, and you'll be good to go. I don't know whether any of you has. I think I have a. And if you want to, yes, it nearly skipped me. If you want to read more about this visualization, data visualization, and the act of storytelling, that is communicating insights as a data professional, I one of the books in the this thing in the Google Classroom, it is called Storytelling. It is in the book section. When you go, you will see it's there. Download it and start reading it. And I'm sure if you read just 10 pages of that, you would really, really have a lot of knowledge. I read it even till this date. All the books I put there are my personal books I use and I read every day. And as I'm speaking to you, my book I'm reading on currently, or I'm planning to read, I've not started yet, is the um, web scraping book, which I'm going to sharpen my web scraping um, abilities to scrape a lot of data for my project I'm working on. So learning never stops, and no one is perfect. You stop when you are done. So once you are not done, you never stop learning. Yeah. So that is what I'll tell you. And then the last thing is most of the I think we've seen with regards to the libraries or Python libraries we use mostly for visualization. This is not the first time you are hearing them. This is not the first time I'm going to see them or mention them to you. Matplotlib is the most popular for 2D. Those charts we've been doing. We also have Plotly, and then we have Seaborn as well, which we will use from tomorrow going. We will start exploring them further. Uh, it's going to be very, very interesting because after all these insights, we carry them on and we pass them, some of them on to ourselves and to stakeholders, and we build models and deploy them. That's awesome. So um, that is the nutshell of, today's episode. Today's session. Yeah. So I don't know whether you have questions, whether you enjoyed it, whether you didn't enjoy. Um, let's ask questions. It's time for questions. I am here. You can ask all your questions, and I'm ready to help you. So let's start with Josephine. Josephine, do you have any question? If you're okay, probably you can give me a thumbs up. I always love it when you ask me a lot of questions. So I'm trying to find the book. Okay, that's awesome. Maybe let me see if I could. Okay, when I finish the class, I'm going to open that for you. I'm going to share my screen on the Google Classroom and then do that. The storytelling book is on data visualization. Yeah, data visualization. Yeah, that's it. I think Fridolin found it. Yeah, it's on data visualization. It has a white background. Storytelling, blah blah blah. Forgotten the exact title. So you can search it. It will be a very powerful tool for you. And once we start, data, the machine learning, there are a lot of books, like three different books there. Depending on the reason why I put all of them there is myself, there are some of the books I don't enjoy reading them. There are some too I really enjoy reading them. So I even have one on how to execute data science projects as a consultant, which is very awesome. That's going to be very useful after you've completed your stuff, how you're going to communicate or how data science project is done as a data consultant. So they are all in there. Advice we always read is very good. Yeah. So Josephine, I'm not sure Josephine. Josephine, have you found the book? Okay. Sure, 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 sure. Okay, that's fine. Um, I'm sure Fridolin has found the book, and everybody can find it. Jude, do you have any questions? Do you have any contributions or suggestions for us? Oh, that's awesome. I'm glad you do. I'm very glad. That's a testimony, a very nice one. Yeah. Fridolin, any question? And Jude, good luck with your project. Myself, I'm a student as well. I'm also a final year student. Vesta was my senior. I'm not sure Vesta was one of that. I'm also working on something in insurance. I'm working on building a model to predict customer churn in the insurance perspective. So I'm working on the data from SIC life insurance, which we would the same data we're actually going to explore and use it to build a model. You know, I'm going to give everything to you. It's a really fresh data set. Yeah, I have the raw data set, and I will let us actually clean it and build model with it. Yeah. So that we have, like, all of us will have a taste of this thing. I don't want to hide anything from you guys. Most of the data I've been giving to you, all of them are real data sets. Some of them I've worked with. The first data, this thing, claims thing I gave to you was from Coronation Insurance, and this one too I'm going to give you from um, SIC Insurance. You even see the customer names, their first names there. So you will see all those stuff there. Probably starting from tomorrow or next week. Yeah. So Fridolin said he doesn't have any question. Ebenezer, Charlie, what's up? You have any question or contributions as well? Anything? Okay, I'm glad you do. Have you found a book or you find later? Okay, yes, sir. I salute you. Vesta, Vesta is my senior. You know, everybody in the building. Vesta is my senior. I'm not sure Vesta is aware of that. Vesta, are you aware? Yeah, I'll be leaving. Although I have a previous, this thing, but my I'm finishing my Ghana tertiary education. I'm in first degree this year. That is, I, yeah, I think 23rd September. I mean August. Sorry, next month August will be my last day. I mean Friday is. Hey, Fridolin, sorry, I beg you, let me finish this thing. Friday is Monday is, no, Vesta is a female, oh, Martin. Vesta is a she, a very nice girl. Vesta, are you, are you in the right state to show us a face, or you are not? Okay, so guys, those who want to see Vesta, you can, you can actually DM her, Vesta B. So there, that's my backies. I don't want to get involved. So you can ask in the group, who is Vesta? Vesta would reply. And then, okay, Josephine says she wants to see you. We want to see you. It's true, all of us. But I'm sure maybe she's not in the right. I don't know. And Vesta has called. Everybody pray for her. Vesta, we wish you, on behalf of all of us, we wish you a speedy recovery. So I'm sure Vesta doesn't have any question as well. Martin, do you have any question? Okay, I'm glad you do. Okay, that's fine. I'm glad you do. Thank you very much for the feedback. Yeah. And back to Fridolin. Fridolin, Charlie, thank you. You have to laugh, no matter the situation. Now, let me just give an advice for like 5 minutes and then we go. We close and we go. My advice, the reason why I'm going to give this advice is that, life is hard. And sometimes everybody needs motivation to, keep on doing what you're doing. Let me just give you a context about how I started my data science career. I started data science. I learned data science for like 2 years solid, and I never made one city from it. Sometimes I ask myself, there are people who started websites, web development. After 3 months, at least they can build some websites. And I wasn't really, I was like, who would hire me to analyze data for him and get money? I thought it wasn't important, honestly. I tried going into cybersecurity. I stopped my career, I mean, 3 times. Even as at these days, I like exploring a lot of cybersecurity stuff. I like a lot of hacking stuff, watching a lot of. I don't know whether you watch Vice News about hacking, and I know Trilogy Media too. Their YouTube channels I watch. They expose hackers and all those stuff. I like exploring the dark web a lot and all those stuff. So I've since I started using computer, I'm used to Windows. I use Linux. Some people say Linux. So that is my listing. But life is not the way you plan. I kept on. I'm not going to say I was motivated. Like Charlie, I gave up a lot of time, but I didn't quit. You give up, you motivate yourself, you come back. One day I was there, and my friend called me. A pharmacy needs someone to build an inventory tracker for him. Very simple drag and drop. So I said, okay, I can use Excel to do because I've been using Excel for like 1.5 years now, every day exploring it, building a lot of things. So I had already even built something similar. So I had to modify. I sold it for 5,400, which I told you guys. And so I said, if someone bought me, small boy like me, my something, I mean my something I made with my mind, 5,400, then I can make a lot. Let me keep it up. Now, so I started, I got the momentum, and then I was really doing well. I mean, within some months, I got some few gigs to. They weren't the big type ones, but still, I wasn't doing the actual machine learning stuff. Although I was making some small coins, but later everything changed. I started making a lot of money, kakra kakra. I was there. Someone reached out to me on LinkedIn. I signed a contract without doing even any interview, and I went on. I worked. I left that company. Another company offer came from Hydra. I worked. I got my money. I left again, and very soon maybe I'll do. And even whilst I'm not working on, I mean working for any company, I have a lot of like consultants. I mean, consultancy, consult for people. Maybe I'm not taking it that more serious, but if today I spend 1 month on LinkedIn actively looking for clients, I can get a lot of gigs and then do and get some money. You get it? Also, I also have a startup. I took you money before you came to learn. You get it? And then very soon I'm going to roll out the second edition. Once yours ends, another one is starting. So my motivation to you is, or my word of advice to all of us. I cannot advise us, but I mean, in the context of data science, I can give some advice, not only for you, but for me as well. I know all of us are matured here. We are not cagey people to come and say this stuff. But no matter the case, no matter who you are, or no matter the purpose of joining this class, my goal or my motivation or my word of advice to you is that pick it serious. Make sure you have a purpose, set a clear goal and vision for yourself so that you learn towards that. For me, my goal is to actually, work like this, and I'm working. You get the thing. I have my personal goals, which very soon you will see some of them rolling out, and I've seen results. It is very hard when you want to be different, but once it starts, like someone will say, Faba, once it starts, like I mean, working out for you, it would everything will become very clear, and you have a lot of motivation to go. But before you get there, you have to, I mean, get something. And I mean, I don't want to see you guys learn this, finish, and then end it there. I want you guys to take it on. Even if you not take data science, you have some exposure, to coding and stuff. You can take it up to whether it is web dev, it is cyber security. You can be a cyber analyst or whatever. You can actually take it on like that, and always work with kind heart. I mean, and let's try to connect with each other and do great. That's all I want to say with us, or I want to say to us today. And thank you for coming. I don't know whether you have any question about that or you have advice too for us. You can raise your hand, I'll call you, and you advise us, all of us. Yeah, Fridolin. Oh, thank you very much too. That's very true. That's a very true thing about us. I mean, from Fridolin. And it's more than true. Yeah. Thank you for sharing. I don't know whether anybody has something to say to. I think Josephine has to advise us. At least she's been very, very hardworking. I'm not saying the rest are not hardworking. I mean, but we want to hear a word from you as well, Josephine. Yeah, give us a just one line advice video. Okay, that's very fine. Thank you very much. We appreciate you. Jude, do you have anything for us? I think Jude is off. Ebenezer, do you have anything for us? Okay, thank you. Vesta, or you want to rest? Okay, so Martin, what about you? Do you have anything for us? Okay, so guys, thank you very much for coming, and I really do appreciate. the efforts you put into, and I'll be glad to. My goal is to give you the best, and I'll be glad to see you thriving. Inshallah. Have a good evening, and mind you, we are actually going to start machine learning tomorrow. Please, it's going to get quite intense. I would advise us we come on board, all the time, so that we don't feel left out, something like that. Thank you very much. See you tomorrow, same time. Bye.